Good morning. Today I want to go a little bit more into the Pythagorean theorem and the unit circle. And I know I made those little screenshot videos, but the computer kept freezing. I put them up, but I'm also going to do it on a video like this. So this way you have multiple resources to help you out. All right, let's just first start. When you're on the unit circle, and this is only for the unit circle. Now, when you're on the unit circle, every quadrant matters. Quadrant 1 has a positive x and a positive y. That means every single function, all functions are positive. Sine, cosine, tangent, positive. Now, quadrant 2 has a negative x coordinate and a positive y. Now, since cosine is x, cosine is negative in this quadrant. Sine is positive. That also makes tangent negative because tangent comes from sine divided by cosine, and a positive divided by negative is a negative. So, quadrant 2 is considered to be sine's quadrant because sine is positive, cosine and tangent are negative. Then you move to quadrant 3. Negative x means cosine is negative. Negative y means sine is negative. Well then, in quadrant 3, if sine and cosine are negative, tangent's positive because tangent is sine divided by cosine, and a double negative is positive. So quadrant 3 is tangent's quadrant. Moving now to quadrant 4. Cosine is positive, sine is negative, which again would make tangent negative. So quadrant 4 is cosine's quadrant. Now this matters because when you now have a point on the unit circle, so let's take problem number 4 from yesterday's packet, which I told you to skip. So on problem number 4, they say there are points on the unit circle. All right, so here's my unit circle. Now, number 4a gives us x equals 3/5. Now, if x equals 3/5, that point, we don't know what the y is, but x was positive. So this could have been in quadrant 1, or this could have been in quadrant 4, because x was positive. I don't know about the y. Was y positive or was y negative? So that's why they said determine all the points. Now, let's also take a look at if I'm on the unit circle and cosine theta equals the x-coordinate 3/5, that means 3 is the adjacent side and 5 is the hypotenuse. So if I were now to finish a triangle, this is saying to me very clearly, I came out 3 for the bottom, and my hypotenuse was 5, and I don't know the altitude. And remember, we need the altitude, the opposite of the angle, to get sine, because that would be opposite. So now I need the Pythagorean theorem, so that's the tie-in. So a squared plus b squared equals c squared, and my altitude is unknown, but my base is 3, and my hypotenuse is 5. So I get a squared is 16, therefore I square root, and a is 4. The altitude is now 4. So once I know that, I now know that my sine, and I'm going to just erase this, hopefully you wrote that down. So now that means y equals the sine of theta, which is now 4/5. And if I want it, the tangent of theta is now equal to 4/3. Now, the new thing that I also put on to the lesson is our reciprocal functions. And so definitely watch the first Screen-O-Matic video because I have everything typed out neatly and beautifully on that. I'm going to go into it very quickly here. A reciprocal, we all know, is a flip. So, reciprocals. If I have cosine of theta is the adjacent over the hypotenuse, then I can have what's called the secant of theta, which would be the hypotenuse over the adjacent. And sine theta is opposite over hypotenuse. And the flip of sine is cosecant, and that would be hypotenuse over opposite, we're flipping it. And then tangent of theta is opposite over adjacent, and the flip would be cotangent of theta, and that would be adjacent over opposite. We have 6 trig functions. Now, you only dealt with 3 of them up until this year, but now we're going to not only take our trig functions, we're going to flip them over. So, and all of this right now is quadrant 1. I am only talking quadrant 1 right now. So, again, I hope you wrote that down because I need to erase with my little board. That's why I was trying to use the Screen-O-Matic and the Smartboard lesson. I don't know how well you'll find it. I mean, I don't think it was that bad. It's just that the computer kept freezing. So now, if I have cosine and I flip cosine to secant, the reciprocal now would be 5/3. So cosine flips to secant. Sine flips to cosecant, and that becomes 5/4. And tangent flips to cotangent, and that would be 3/4. Now, the one thing I want you to truly notice today, cosine and sine have to be proper fractions. You cannot have cosine and sine if the top is not smaller than the bottom. However, tangent doesn't have to follow that rule, and neither do the reciprocals. So this was everything that would happen if I was in quadrant 1. Now, if I was in quadrant 4, I'm just going to get rid of this now, the whole thing. If this now were a quadrant 4, 3/5, again, this is my cosine. Cosine theta is 3/5, making my reciprocal my secant still 5/3. Now what happens is y is negative in quadrant 4. So now the sine of theta is negative 4/5. See, because if the altitude is 4, the altitude is still 4. It's just the location. Positives and negatives in trigonometry are all about the location. So then the flip of this, the cosecant, would be negative 5/4. Now the tangent, which is equal to sine divided by cosine, or opposite over adjacent, gives me negative 4/3. And it's negative again because sine was negative. And tangent, the y, it's going down. On a triangle, it's written as positive, but the location was it went down. So the positive and negative signs are all about our location. and its reciprocal cotangent would now be -3/4. So when they're asking about all possibilities, it's going back to where are you located? Because technically every function can be positive in 2 quadrants and negative in 2 quadrants. You're always positive in quadrant 1, and then depending upon which function you are, your other positive quadrant rolls around the graph, rolls around the unit circle. So when you then look at page 9 on your packet, now page 9 on your packet is just all about the Pythagorean theorem, and it's all about finding all your ratios. So that one's actually not that bad. I'm asking you to do 3 through 9 odd, but let's take a look at, say, number 4. Number 4 gives me numbers 5, 12, and 13. So now we're on page 9. And number 4 on page 9 gives me 5, 12, and 13. And the directions say, given the lengths of the sides of a right triangle, angle C is the right angle, and find the sine, cosine, tangent of A. Now, your answer is going to really be the way you set it up. The longest side is always the hypotenuse. So if I set this up, and I say, okay, here's A, here's B, here's C, and I go smallest to largest, the longest side has to be the hypotenuse. Just to tie into geometry, largest angle is opposite the largest side, smallest angle opposite the smallest side, if you remember that. So now, they gave me the right triangle. I just had to figure out who's the longest side. And now, since I decided that 5 was my A, the sine of A, opposite to hypotenuse, and so now then that gives me the cosecant of A, 13/5. So reciprocals. And if I give you the cosine of A, I would have 12/13. And the reciprocal secant is simply 13/12. And then tangent, opposite to hypotenuse, tangent of A, and that would be 5 to 12. 5 to 12, and then my flip cotangent would be, A, 12/5. So once you know one, you know them all. Once you know one, you know them all. So pretty straightforward. Now, that's being that I put the 5 as the opposite side. Had I labeled it differently, and I'm not going to ask you to do it each way. So basically, as long as you know, whatever way you label is going to be fine with me. But let's just say this is you, and you had this label. You had the 5 on the bottom and the 12. Well, that just changes life because now your sine is 12/13, and your cosecant would be 13/12, and your cosine would have been 5 to 13, and then your secant would have been 13/5, and your tangent would have been 12/5. And your cotangent would have been 5/12. So notice they would have just been opposite. So I'm not going to ask you to do labeling 2 ways. Like whichever way you label, I'm going to be fine with. Just make sure the longest side is the hypotenuse, and then you are absolutely fine. So that's page 9, and these are not on the unit circle. These are just finding ratios. When you get to page 10, we're back on the unit circle. And they're giving you coordinates, so they're really precise with where it is that you are. For instance, let me do number 6. So let me go to number 10, page 10, and let me just do number 6, because on page 10 I'm asking you to do the odd also. All right, so page 10, and let's do number 6 now. Number 6 gives me the ordered pair radical 5 over 5. And negative 2 rad 5. Or is that a negative 2 rad 5? Let me just look at that a little bit more closely. Yes, that to me absolutely looks like a negative 2 rad 5 over 5. And this one's quadrant 4 again. Maybe I don't want to do number 6. I don't want to do another quadrant 4. Let me do... Wow, they seem to have only given mostly quadrant 4. Well, that's silliness. All right, I guess I'm doing number 6. All right, so this is quadrant 4. If I were to draw my unit circle, and notice I'm just like really focusing on the point, this is the point rad 5 over 5, and this is negative 2 rad 5 over 5. So this point here, this is my cosine, and this is my sine. And I know I'm in quadrant 4 because x is positive and y is negative. So there's my sine, there's my cosine. Those parts are done. And so therefore then, the tangent would be sine divided by cosine. Or if I think about this in terms of labeling a triangle, which if you label your triangle, it's always going to be easier. Cosine is adjacent over hypotenuse. So my adjacent side would be rad 5 and my hypotenuse is 5. And then sine is opposite over hypotenuse. And this would be 2 rad 5 and the hypotenuse is 5. Now the negative again was the location going down. That is location. And that is why I am in quadrant 4. Positive x, negative y. Positive cosine, negative sine. So now if I want to do my tangent would be 2 rad 5 over rad 5. Well, that cancels. So my tangent is 2. And now I know my cosine, my sine, my tangent. Let's flip cosine. If I flipped cosine, I would have secant. And that flip would be 5 over rad 5, which we have to rationalize because you know we don't keep radicals in the denominator. So this would be rad 5 over rad 5. And that now gives us 5 rad 5 over 5. Yikes, I have to reduce rad 5. Secant rad 5. And then the cosecant, if I now flip my sine, I have 5 over 2 rad 5, and it's negative. And again, I can't have a radical, so I'm going to rationalize. Rad 5 over rad 5. And now that's going to give me negative 5 rad 5 over 2 and 5. Rad 5 times rad 5 is 5, so 2 times 5 is 10. And 5 and 10 reduce to 1/2. So now I have negative 1 rad 5 over 2 for the cotangent. Excuse me, the cosecant. Cotangent, super easy. You flip over 2, you get 1/2. So cotangent. All right. So guys, do your best. Do your best. Watch these screenshots. This video will help you, and I think you'll be okay today. Again, let me know if you're not, because I will answer your questions. You got to give me specific questions, though, and let me know if it helps. Like, if I answer you, try, and then let me know if I helped you or not. Because if I didn't help you, I'll try again a different way. That's just, I want you to learn. All right. Have a nice day. Bye-bye.